Now look into another method of separation called crystallization. The word crystal indicates we obtain pure solids as crystals from their solutions. This method is usually used to purify solids. This method is better than evaporation because in evaporation, when the substance is heated, the solid substance may get decomposed. However, this is not seen in crystallization. Secondly, there are no impurities that are left behind after crystallization, whereas in evaporation, the impurities may contaminate the solid in the process. Let us have a quick look as to how crystallization works. Take an impure copper sulfate in a china dish and dissolve it in some amount of water. The color of this water will be blue. It contains impurities as well as copper sulfate and water. Filter these impurities using a filter paper. The filtrate that is left, then evaporate water from that filtrate and try to obtain a saturated solution. I hope you remember what a saturated solution means. Once you get the saturated solution, cover the solution with a filter paper and leave it to cool for a day time at room temperature. What we see after the time passes or after the substance gets cooled down, we see crystals of copper sulfate left in the china dish. These crystals are absolutely pure. All the impurities have been removed. We will also see a demo of the same experiment in school in future. Let us try and find out what are the applications. You remember we obtain salt from seawater. So crystallization is a method that is deployed to purify salt which we get from the sea. Then separate crystals of alum. I hope you remember what is alum. We normally use it to allow dirt or impurities to coagulate and then they settle at the base of the bottle. That is what is alum does. But to obtain that pure alum, we need to use method of crystallization. You may also go through the link that is given below to give you a visual on how crystallization actually works. Distillation, a separation technique that is used when we want to separate two miscible liquids. In the earlier videos, we saw that if we want to separate two immiscible liquids, we can put them in a separating funnel, allow it to stand. Depending on densities, they will form two layers and then we can use or then we can remove them. However, if the two liquids are miscible, they are soluble into each other and we cannot identify which one is which based on their densities or their solubilities, then we use distillation. Benefit is it does not it is far more better than other separation techniques. Also, we can use this method to separate only when the two liquids do not get decomposed on boiling, because we have to heat the solution, and if they are going to get decomposed, then we will not be able to obtain them. Also, the two liquids which are miscible, they should have their difference in their boiling point should be greater than 25 K. So if I say one of the liquid boils at say 25 K, the other boiling point should be more than 50 K. Otherwise, it is difficult to separate them using distillation. There is a different method of distillation which we will see in the next video. Now, see the picture. It talks about an experimental setup where we want to separate acetone from water. We put acetone and water mixture in a round bottom flask. This is used in the distillation method, so it is called as a distillation flask. We fit a thermometer to ensure that we are recording temperatures, because a particular liquid will boil at a particular temperature and will pass on through that side tube or the condensing tube and get collected in the adjacent beaker. Okay. What we see is when we heat this entire solution of acetone and water, acetone vaporizes at a specific temperature and it goes through the condenser outlet and gets collected in the flask which is there at the end. Whereas the water will remain in the flask. This is possible because acetone has a different boiling point, water has a different boiling point. So thus, conclusion is we can separate two miscible components through distillation. This technique is usually used in production of alcoholic beverages, then to convert salt water to fresh water, as well as in the pharmaceutical industry. The link given below will help you visualize the distillation experiment. Do watch it.